Thank you very much for attending today. It's amazing how many of you got here, so thank you very much. And if Johan tried to answer the question why spec-driven development, I'll try to explain how to do spec-driven development. And actually, this is exactly why we started CodePlain a year ago. So the goal of CodePlain is to develop and promote Plain. So the specification language that we hope will represent the future of software development. And we are super happy that on this journey we are supported by some amazing people. So it's not just Johan, and one other angel investor that I really like to point out is Damir Sabol, so the founder of Photomat. And we also have support from Silicon Gardens, and we have Vuk here. Vuk, can you raise your hand? So, thank you. So they have money, so just a hint. And yeah, we are now 5 engineers and 1 product designer. Of course, looking for more people to join, so check our career page. And what was the most valuable over the past year was our free design partners, Devrev, Incode, and Haiku, because without them, we could not get where we are today. And today, where we are is that actually we are launching in public beta the first version of our product. So Predrag will talk more about that. But I'd like to first touch on the design partners, because we started from the get-go from the concrete problems. So we are super fortunate here in Ljubljana that we have 2 amazing companies. The first is Devrev, and we have Drago Radin here. And Drago, can you maybe just raise a hand so that people know you? So he's technical director at Devrev, and they have been amazing partner to work for the past, 10 months. And also a special shout out to Patricia, who was our first user. And so we apologize. So that was, so thanks to you, we managed to improve our system, but I know it was painful. And another great company that we have here in Ljubljana is Haiku. So we have CTO Goran here. Goran, where are you? There. So thank you. The third design partner is actually Incode. They have strong Serbian roots. They are based in San Francisco, but they have 150 engineers in Serbia. So they were visiting us a month ago, but could not come for this event because they have some other things going. But the thing that connects these 3 design partners is their use case. So all these 3 companies have the problem of scaling integrations. So Devrev, Haiku needs to connect with hundreds of SaaS vendors to pull in the information. Incode, which is Know Your Customer provider, needs to connect with hundreds of government data providers across the world. And developing those integrations is boring, hard to maintain, and something that we could not fully automate that up until now. And I know that myself because Clean Shelf, so the startup I had before CodePlain, was all about integration. So we were an expense SaaS management solution that connected with thousands of integrations. And for example, Matjaž, who was my first engineer at Clean Shelf, built many of those integrations himself. So if you want to feel the pain of integrations, he's the best person to tell you about it. So that was the first year. But we actually have a secret master plan. So for us, the integrations are kind of the beachhead, where we could already make spec-driven development work. So Johan mentioned that probably the key challenge with SpecLang originally was not the approach, it was the application domain. So the key kind of innovation we did at codeplain was actually identifying a domain where this approach not only works today, but delivers value. And this is where we are today. So we want to get to 500 developers by using codeplain by the end of this year, exclusively using the integration use case. Because here we have great case studies with DevRev, we have great case studies with Haiku and Encode, and this is where we will scale commercially this year. But this is just the beginning. And actually, so now I can expose why you are all here. You're part of a secret plan. So I hope that many of you will get interest in this approach and try it out. And what we are looking at codeplain are really, really strange use cases that you will come up. So we have some ideas that we will explore, but our imagination, especially mine, is super poor. So we cannot imagine all the little things where this approach could already work. So that's why we are putting this out. That's why we are giving you all some free rendering credits so that you can play with it and maybe come back with information. Hey, how about applying this to this particular niche use case? And the more niche, the more crazy, the more we like it. So don't hold back. The stupidest, there are no stupid ideas. There are only interesting ideas. So that's what we want to get over the next 2 years. Find niche use cases so that we find where this approach not only works, but is also already fully adopted by developers and by their bosses, so that it delivers actual value. And then from there, it will be easy. That's the rest is just scaling. So traditional programming languages are 60 years old. And we heard before there are at least some people in this room who would prefer to spend until their retirement coding in traditional programming languages. Well, I'm not one of those. And the reasons are things on the right. So we would certainly love to retain deterministic control, reusability, teamwork. But this specification by coding, that's so inefficient. So for example, I don't know, you want to do a simple query from the database. You know exactly what you want, how to describe in that language, in natural language, but then you need to type this SQL. Come on, we can do better. And specifying by coding is just one of many, many ways how you can specify the performance, the functionality of software. And up to now, we could not do anything else but code. Now we can. And this is why this is super exciting, because we are innovating new ways how to develop software. The other problem, which is super, super painful if you ever had to take over existing project, especially it was big, you were stuck with the code, you had no idea what the initial intention was, and you were guessing. And probably you did some changes, and there was one user coming back and say, you created a bug. And that's how you learn the intent behind the code. That's not how I would like to see the future to look like. And finally, the key challenge that actually is with existing ways of coding is what I call functionality blending. So you basically want software to do things for you. But when you implement that in code, it looks like putting everything in Blender, and you can't really get what were the initial ingredients. And there was a really good attempt at one theoretical approach to improving how programming could be improved, called aspect-oriented programming, that tried to address this problem, but it was unsuccessful. for a lot of reasons. And spec-driven development, I see it in many ways realizing the dream of aspect-oriented programming, where the programmers could really focus on one thing at a time, while something, now this something are LLMs, would blend that into executable code. So what is codeplain, or what we want to do is basically super simple. So we want to make specifications source of truth, and then we want to have deterministic rendering, and we want this rendering to happen immediately so that you get immediate feedback what the change in spec mean to your working software, so that you have this iterative loop that we got used to in traditional programming languages. And then our assumption is that programmers are really good at connecting things, that we will be connecting how a change in spec influences the working software, and we will get this direct connection. I do this change in spec, this is how it reflects in working software. So that's what we do at codeplain. Let me first touch on the language. So this is its structure. So natural language is great because it's so amazingly expressive. But actually it's too expressive. We don't need so much expressivity. So whenever you go into more details, for example, when you write technical documentation, we are already using constrained natural language. That means that you have constrained vocabulary. So if any of you ever did technical writing, the first thing for extensive technical documentation is you create vocabulary and you define it. These are exactly the concepts in plain. And the rest are basically how to specify different elements of different aspects of your implementation. So of course, we have the functionality, but we also need to specify how we want that functionality to be turned into implementation code. That's the first part. Then the key to our approach is extensive testing. So we create 10 times more test code than implementation code. That's how we achieve close to deterministic performance. So for some of the examples, I run them 100 times. Every time they generate exactly the same functionality. That's achieved through extensive testing, and it's not achieved through LLM determinism. We are now in the 6th generation of LLM. We started with ChatGPT 3.5, we moved to ChatGPT 4, Claude Sonnet, several versions, we are now on Gemini. It's no longer up to the underlying model, it's up to our system on top of it. And our system, so the state machine rendering agent that we built, of course, it's built on LLM, but we treat LLM as an engine. And on top of engine, we build the harness to control that engine and harness its power while handling the inefficiencies that it has. And actually, the approach is quite simple in principle. So you take functionality one by one, you generate code and tests, you run those. If everything works, great, let's go to the next functionality. If there are errors, you feed them back into LLM, fix the code until everything is green, and you move on. We retain conformance tests for all existing functionality. If there are any regression, we detect that and fix that. So these are a bit more details about how plain looks like. So we heavily support reuse and modularity. So one of the key challenges that I have currently with all agentic approach is this lack of reusability on the spec level. So you need to prompt every time. The only way how to reuse things is on the code level. In plain, you can import requirements. You can have a library of requirements. So in this example, which is Task Manager written in React, almost all complexity of technology is hidden in the imported requirements. And a lot of that is also modularized into a boilerplate module. So in the version that is now publicly available, the biggest change from what some of you saw maybe before is that we now fully support reuse of specifications and modular structure. So the big specification can be broken down into individual modules, and each module developed independently. That's the only way how you can build bigger systems. And I already talked about concepts. So this is direct analogy from the definitions in legal documents or glossary in technical writing. You want your concepts explicit and you want them well defined, because if you do that, you remove majority of ambiguity. So the nouns is what is typically not well defined, and if you define it well, things become really, really precise. And to just give you a bit of flavor, what is in the boilerplate. So sorry, that was this is the template, not the boilerplate. So you write this once. So how, for example, what are the details of React application? What is your style of writing on React? And then you define how you want to test it. And you put that into a template. And this is something you can reuse across all your applications. So whoever will be sitting at my desk at the workshop session, this is what we will look in, because for the front end, there are some super interesting problems, and a lot of you here in the room are front-end experts, and we can have really good discussion, because Johan, I think we are getting ready to handle also user interfaces. So we like integrations because they don't have user interfaces. They get JSONs in, JSONs out, which are super easy to test, but I think it will be super interesting to develop user interfaces using spec-driven development. That's when things get really, really interesting and also fun. As Johan said, his presentation at GitHub Universe 2 years ago was about changing the user interface. This is what makes software development sexy. Integrations are great, but definitely they are not sexy. And let me finish with actual current limitations of our approach. So the key limitation is on complexity. So please don't try to go over 50 functional specs at the moment. The largest code base that we successfully generated in predictable and controllable way is 20,000 lines of Java code. And this is the maximum we can do at the moment. We might even constrain it because it will provide for better experience. So when I was talking about niche use cases, we are looking for new niche use cases that are below 50 functionalities, which is, let's say, 5,000 lines of Python or TypeScript code. So not big things, but I believe that some use cases can be super valuable despite these limitations. We are pushing forward, and we want to get to approximately 150 specs by the end of this year, 1,000 specs by next year, and that will open a lot of new use cases. And how we plan to do that? Of course, LLMs keep on improving. The better the engine, the better our system, but we are not at mercy of LLM providers. We are squeezing out of LLMs increasingly more by developing a better harness. The second limitation currently is rendering speed. So I will ask you for some patience. It takes time. It takes 10 times less time than 6 months ago. Because for example, Gemini 3, for us, it was a game changer. And also our system is improving all the time. So now we are talking about minutes between the time you change the spec and the time you see the change reflected in the code. We want to go into seconds. So my inspiration is TypeScript. So TypeScript, we typically don't even notice that there is a compiler in the back taking your TypeScript into JavaScript because it works so fast. And I bet everyone in this room that 10 years from now, no one will notice that there will be a renderer between your specs and working software doing all the things we are discussing now. So that's what we want to achieve, that no one notice codeplain at all. We want developers focus on specs, on working software, and we want to blend in the back, provide technology that works without you noticing it. Finally, and that's probably the biggest challenge, we have very little idea how to debug specs. The conflicting requirements, that is solved. So you get conflicting tests, and it's pretty, so if the two, so for example, if you have a requirement, a specification, this button should be blue, and the next specification is this button should be red, the test will not pass, our system will detect conflict. But there are so many other things that we need to do in order to provide good feedback to developers. What's wrong with the specs when software is not working as expected? And this is where a big focus for us will be over this and next year. And some of the ideas that we have here is behavior tracing. So you see something not working in the software, where in the specs is the reason for this misbehavior, or the other way around. So I have this functional spec, how does it reflect into working software? And another one, so these are just the list of ideas. There are probably many other tools that we need to develop, is spec interpretation. So, okay, you wrote this, but did LLM really understood this, or it understood it someone differently? So communicating back the intent, how it was understood, that's one of the key things. And actually, this is how US Navy does. So when US Navy sailor gets an instruction, he must always repeat it back, because that's how the officer knows that the sailor got it right. And something in this vein will have to be invented also for spec-driven development, to properly have this communication between man and machine, that the intent was properly understood and properly implemented in the code. And before concluding and moving to the questions, let me just finish with one super strong belief that I have. So spec-driven development has nothing to do with machines or LLMs or anything other than humans. Spec-driven development is about humans writing software for us so that we read it 6 months from now when we need to maintain it, or when we send the specs to review to our colleague, and we want them to understand what was the intent that we had writing the specs, what problem we were solving, and specs are for humans. And let me conclude here, and thank you again, and happy to take your questions. Jakob, prosim.
Testing, cool. Yeah, first of all, very cool. I'm just going to ask you the same question I wanted to ask you, Johan. I think you're interchangeable in this regard. So just first, to make sure that I understand correctly, your view of the end state is that in a Git repo, you have nothing but like markdown files. It's all specs and everything else is generated, like is an eventual end state.
So there might be need for code, but there shouldn't be need for human to review the code. And why we need code is to freeze the decisions which are not important for the human. So you can observe it this yourself. When you are coding, you're given some requirements from your product manager, and these requirements are heavily underspecified. And as developers, you are probably doing 50, 100 decisions a day, and you are storing those decisions into code. So it's not entirely sure how we will go about storing these micro decisions, whether it will be a separate implementation lock or it might actually be in the code. The key thing is human should not review that because we want 10 times faster software development, and that's not possible if human needs to review the code.
Cool. So basically like a log file for a package manager. Yeah, very cool.
Sergey.
Hi. Thanks a lot. Just one observation, perhaps. Shouldn't the end goal be that the entire interaction between human and machine's natural language and the spec is a generated output of the interaction? So, for instance, currently in current agentic coding, what you do is, right, you work on something, you're fast, you hit a wall, either you break down, right, or you optimize your, let's say, agent's MD file or code MD file, right? And this is how you teach, and basically you close the feedback loop, right? So that future features are in line with your envisioned, let's say, architecture, design decisions, etc., right? To that point, I'm the problem with me personally, right? I'm very opinionated, right? And I love writing code in language A, right? And I don't like writing code in language B, etc. And agentic completely wiped this, right? This doesn't exist anymore, right? And what I'm quite concerned is that you're now making a spec language, and I ultimately wouldn't want to care about the spec of your language, right? The idea is fantastic in terms of it's going to additionally provide a feedback loop into the agentic coding because the spec is going to define 10 times more things than currently, right? The main question from my perspective is, why wouldn't the main interaction between human and machine be just natural language? Because this is, I think, from my perspective, again, completely subjective, the way forward. Yeah.
Fully agree. Actually, I share your dream. But we are developing professional software. So we want to get to that dream in a controllable and predictable way so that a change, we know what the result produce. And currently we can do that, but in between is magic, that is LLM. And sometimes it works, sometimes it doesn't. And the only tool at our disposal is hope and prayer. And I think engineers should not rely on hope and prayer, but on engineering principles. So currently, if you, for example, write JavaScript, your JavaScript does not translate directly into machine code, but you have VM in between. Because it has turned out that that's a really great engineering layer in between to make everything much more efficient. So now at this stage, humans will have to review specifications in plain language, but maybe in 10 years this will become a layer beneath, and we will invent a new abstraction layer on top of it, which will be even more human.
English.
It might be English, but the key thing is that currently the jump from requirements to working software is too big. So the divide from requirements specified by, for example, non-developer and working software is huge. And what we want actually achieve, or what is needed to achieve, is series of intermediary layers, each becoming more precise in order to predictably generate software that we want, if we want it to work reliably, predictably, performantly.
Yeah, I mean, I think that you've cracked the code with the templates, right? So with your imports, right? Mm-hmm. So honestly, again, I don't know a thing about React Native development, etc., etc. I could have potentially a source of X different templates for best practices in React Native, which will basically pre-populate everything for me, and then I'll just focus on the specs, right?
Exactly. And you will notice in Plain, we have now this folder called Plain modules. There is direct inspiration from Node modules for it. Yeah, because we would like people to build on top of these modules, like building blocks, without the need to really understand how this works. But there is some human who understands that, who maintains these building blocks and can guarantee that they work as expected.
Thanks.
Can I add something to that? I'll try to speak louder. So I think. I can also. Hello. Yeah. So I think raw English is not necessarily the end goal. In that we see that in a lot of other domains where you have sort of forms of formulaisms that support a particular way of thinking or working about something. So in a lot of domains, you sort of, they call them sometimes mental tools or something like that. I think a language like Plain can help support the mental process of precisely and unambiguously writing what you want your software to know. And you can think of something that is less prescriptive than Plain, lying above Plain, and you can think of 100 such things, which will probably evolve, and people will pick their favorite ones, and you don't like this one, and someone else likes that one, and they compile down to Plain, and then Plain compiles down to executable code. You could imagine a funnel like that, but I think
it's middle out. It's not
right. The point I'm trying to make is that just writing raw English unstructured is not necessarily the best way forward for like big projects where you want to collaborate.
A very short one. Is codeplain implemented in Plain?
No.
Wow.
Because we are above 50 functional requirements. For example, NVIDIA implemented a dashboard for lengthsmith in Plain. That is already something we can do, but our renderer is definitely into hundreds, if not thousands of functional requirements. So we are not yet in the position to eat our own dog food, but we would like to be there in a couple of years.
Thank you for the presentation. I have a more philosophical question about the future of programming languages. So today, if I want to do a project, I decide whether I do, I don't know, Laravel because I like it, or because tech bros use Next.js, I'm going to use that. When I use Plain, do I even care about the framework? So when we reach that 10x in a couple of years, are we still writing? You had in the boilerplate of your Plain language, you imported a React boilerplate. When we reach 10x, do we care about the frameworks and languages at all? Who decides that? How does it work in your vision?
So I think the story of LLVM is instructive. I don't think that any developer writes LLVM native code. It was invented to make compilers easier to write. So increasingly, I see the need for both frameworks as programming languages, which will be good for LLMs, not for humans. And what that means can be really, really interesting. So there is some research that, for example, Chinese is much better for LLMs than English. So it's pure historic coincidence that we have programming languages in English, kind of might be much more sensible from LLM perspective to have Chinese language as the base for programming languages.
Maybe a sub question, which was part of the question, is whether if I will need to specify whether I want to use JavaScript or React in 10 years, or is right now in Plain, if I understand, you specify you're going to use Python or something like that. So if it doesn't matter, if I don't look at the code, why do I need to specify?
So the reason why you actually need to specify it is not because of the code, but because of running the code. So codeplain generates code, which is meant to run in your environment, and it should conform to your how you do things. And so one direction that many code generation tools are taking, for example, Lovable, is that they heavily constrain the execution environment because they can then do much more predictable code generation. So we have this approach because of the current circumstances where our use case is in scaling integrations. And for example, with DevRev, they have TypeScript integrations, they have their own system, and that's why we need to support that. With Haiku, they have Java-based integrations, we need to support that. And because of our use case, we took that approach, but for example, Lovable took much more technology constraint approach, and they do it that way. So I think there will be all kinds of approaches here depending on the use case.
Just the last statement. So if I'm abstracting the code, I should be abstracting the infrastructure where I deploy this. So I shouldn't care about where is it deployed on AWS, and Docker. I don't care if I don't care what the code is.
So it's much easier to generate code than run the code. We therefore focused on the easier problem. If you want to have something to do or some idea for a startup, there is so much opportunity now to run the code, run the tests, because this is what agentic approach will hit later this year. We already hit it ourselves. But the guys in agentic coding are at least a year behind us. And this will be a huge, huge problem. So how do you run 1,000 tests in 1 second? How do you do that? That's something we need to fix that. How do you make it so you have a developer who's a bit higher level? They don't need to review the code, but they need to know a lot of details how the technology is run. That also doesn't feel the right approach to 10x software development. So I think these are the roadblocks that we will hit this year. So we already hit them at codeplain, but the wider agentic coding will hit them later this year when they get to our level. So if you ask me, so Claude Code is, so if we are at 50 functional specifications that we can predictably render in code, Claude Code is at 5, so 10 times smaller in this ability to turn specs into code predictably and repeatably.
One way to 10x is to make us 10x more productive. Another is to democratize. How many thousands people to every one developer? Then it becomes 1,000x of the developer. Are you thinking anything in that direction?
So that's what Lovable is doing. For that, you need to constrain the technology. It was entirely my personal choice. I love working with developers. So I was having the luxury of picking my users. Thank you. And it was intentional choice. I want to, so when I first set on building codeplain, my wish was to help developers adopt AI-powered software development in the way that works for you, not how it's pushed on you by CTOs and VPs of engineering. Sorry, Jost. Josh has a question. And okay, this and one more, and then we need to.
Dusan, how is plain gonna preserve the technical joy that developers have while writing code? That vibe coding might lose.
So first, Tjaž is our Gen Z member. He was born in 2001. So he never got the joy of writing assembler on VAX so for us, a bit older people, what you kids do now is all scripting languages. That's not real coding. So does that answer your question?
So we never had the joy.
You never had the joy. One last question, and then I suggest.
So I was triggered by your love of working with developers. I do not share it. So I want to ask you a provocative question, as it were. When are you going to organize another meetup like this, and the room's going to be filled with product managers who are tech savvy and not a bunch of skeptic 40-plus-year-old old farts like me?
So I'm guest at the next Product Tank meetup on 22nd of April. So that's the immediate answer to you. But it's we are definitely already much more human than previous generations of computer scientists who had to, connect wires or plug holes into punch cards and do some pretty crazy stuff. So we are definitely getting closer to human brain thinking. Yeah, but it's a process. So I have hope.